Hello everyone, welcome to the Transformer Design course. So here we will learn about the design, engineering, selection, manufacturing and assembly of transformer. So what is the main purpose of selection of transformer? So every time we select a transformer, we have to know some key important purpose why we are selecting the transformer. So the first and foremost important point is optimized selection of transformer which fits the purpose. So based on our requirement, we have to see and look forward that the transformer which we are selecting suits the purpose of its selection. What I mean to say here is, as we know, in the entire power flow, there are stages of generation, transmission and distribution. So in generation also, for stepping up the voltage, we need transformer which has a specific design as well as a purpose. Similarly, for transmission, for long distance power transmission, we have to use transmission transformers which have a specific design for its requirement. And finally, on the distribution side, we have distribution transformers for final distribution to the load. Second foremost important point would be reliability and sustainability. So whatever we design, we have to be very sure that the transformer selected is reliable in operation and also sustainable. Third point would be safety to the working professional during operation and maintenance. So here I would like to highlight one important point. Many a times we as design engineers, when we select or design any electrical equipment, we are doing the same maybe in an office, but the final equipment when delivered on site will be handled and operated by operations and maintenance team. So we have to be very sure that adequate safety is considered while ensuring the design of the transformer or any particular electrical equipment. So that is a very important aspect. And fourthly, I would like to emphasize on the minimum failure rate. So the transformer that we select, that has to have a very minimum failure rates. So the reason for specifying this particular point is, in India or in any country, there are multiple manufacturers of any specific equipment. So if I consider transformer, there are many transformer manufacturers across India. Whilst there are few players in India who have a very high quality of manufacturing in their assembly line, and also there are some manufacturers where the performance is not up to the mark. So there you can check the same with cost, means they can deliver you a same product at a much cheaper price than the A1 players are delivering currently in market. But just for the sake of cost, we should not directly go for selecting those transformers which may have a fatal failure rate. As we all know, in the power distribution or transmission and generation, transformer plays a pivotal role in the power systems. So the failure rate for the transformer has to be almost nil, that is negligible. Coming to important codes and standards. So while designing any equipment, one of the most important parameter that as design engineer we have to keep in our mind is the relevant codes, standard, manual or local regulations that will govern the specific design requirement of the equipment. So for transformer, you can see first we have our CBIP manual on transformer. Second is for dry type transformer, we use IS 11171. This is for exclusively dry type transformer. Energy efficient transformer up to 2.5 MVA shall be designed as per IS 1180. and any other rating beyond 2.5 MVA has to be designed either by IS 2026 for Indian standard or IEC 60076, which is for power transformer. So IEC 60076 is the IEC version, and its relevant Indian standard stands is IS 2026. So one important point I would like to highlight in this particular slide is, if anyone wishes to be a very good design engineer, then the foremost important thing that I would like to emphasize is he or she has to go in detail through all the relevant codes and standards. So these are the key transformer design codes and standards. However, apart from these, there may be some other relevant codes and standards which are applicable, which I may not have highlighted here. But at least these 5 codes and standards has to be thoroughly read, wherein the details of design, testing, assembly and all other important parameters are mentioned in this standard. And while reading through the standard, please ensure that you are going through the latest version of the standard and not the older version or any discarded standard. So that is one important point I would like to highlight at this point of time. Moving on. So transformers can be broadly classified into 2 categories. The first being oil type, where the core and winding assembly are placed in a dielectric medium of oil, and dry type, as the name suggests, it will not have any oil, it would be in a dry state. So now selection of dry type versus oil type transformer. So while there are lot of discussions happening all over the world across the selection of dry type versus oil type transformer, it is important that as a design engineer we should be aware that which one to opt for and which suits the best fit for our particular requirement. So here I have specified 1, 2, 3, 4, 5, 6, 7 important points which will help us in selecting whether to go for dry type transformer or oil type transformer. So the first point, as you can see, is important point of maintenance. So oil cooled transformer requires more maintenance procedure as it has oil and also lot of important ancillaries which are part of the transformer. However, also the oil has to be sampled from time to time to check the quality of the oil, whether it has been deteriorated, contaminated or not, with respect to the chemical environment or the reaction that is happening inside. Second and important point would be cost. So cost is always 2 types. What we call in industry standards, one is called capex and another is called opex. So capex specifically says about the capital investment that you are doing while purchasing any equipment, and opex would be the operational cost that you would incur throughout running the equipment for a particular span of time. So initial and operating is specified here. So compared to oil cooled, dry type has significantly higher operating loss. So oil filled transformer have a higher standard energy efficiency and as a result have a higher lifespan than the dry type. Third point I would emphasize on noise. So oil cooled transformer have a lower operating sound level, thus less noise pollution than dry type. So I would also like to highlight here is, for noise limits there are specific standards, but for a particular plant, Central Board of Pollution Control, CPCB, so there are CPCB limits which govern the actual noise pollution for a particular plant. So at daytime it can be 75 dB and at night time it has to be 70 dB as per the current standard. Third would be recyclability. So definitely, as we say, we need to recycle our products. So we have to see from the environment point of view as well. So the end of life recycling for dry type is limited, while oil units boost an easier core coil reclamation. Oil could have superior operating life and maintainability, producing less waste and require less replacements and labor. The fifth point would be on efficiency. So as we say, efficiency plays a very pivotal role in selecting the type of transformer, whether we should go for a dry type or oil type transformer. Efficiency by fundamental, we all know it's output by input, right? So better efficiency, so better is the low loss, and finally it's pocket friendly. So dry type transformer are larger units because they don't have insulation oil in the medium, limited in voltage and size, making them more prone to overheating if they experience overload. But again, I would emphasize here on the overload part. Dry type transformer are mainly categorized into two parts, mainly cast resin type and VPI, vacuum pressure impregnated type. So based on that, you can go for the selection of which one to go for overloading. So if you have overloading, you can go for either VPI type or CRT type based on your requirements. As a result, they have a higher electrical losses and it is more expensive to maintain dry type power supply over the time. Oil cooled units are smaller in footprint and considered to be more efficient. They require less demand and create a smaller environmental footprint. So that is also one important point. While you are selecting transformer, while in the plot plan you are selecting the transformer bay, please, based on the vendor document available or the catalog, check for the footprint. So for a higher rating transformer, let's say more than 3 MV, 5 MV or something, you have to look for the footprint of oil type versus dry type. So if you select a bay of transformer, let's say 7 by 7 meter for a 3 MVA transformer, oil type, it may or may not suffice the footprint if we go and opt for a dry type transformer at a later stage. So that is one important aspect I wanted to highlight. We have to be very sure while selecting at the preliminary stage, we go for either dry type or oil type transformers. Regarding voltage capabilities, dry type transformers are designed to handle small to medium MVA and voltage ratings. So currently many manufacturers have upgraded their manufacturing capabilities where they offer quite a higher MVA rated dry type transformers, making them ideal for many applications. On the other hand, oil type transformer can handle heavier loads, so they can be used for higher voltages and for larger ratings compared to the dry type transformer. Location. So location of the transformer will be the biggest determinant for which you will need. Yeah, it's a very important point I would like to highlight here. If you see the National Building Code 2016 regulations, so there are restrictions and clear guidance on selecting an installation of the transformer, if it's oil type or if it's dry type transformer. So while selecting the transformer, we have to go by the local authority codes and regulations. Also, based on the NBC requirements mentioned, the electrical inspectorate will come for inspection and approval of your transformer, without which you cannot charge the transformer at your site. So location of transformer will be very important and will play a pivotal role in the selection. Dry type can be used inside the building and near to the buildings as well, but please, we have to refer the National Building Code 2016, I repeat, National Building Code NBC, wherein the requirements are clearly being laid out. If I have to install a dry type transformer in the building, what are the prerequisites which I had to follow? So they are considered little environmental safer as they don't have any oil which is prone to danger. Dry type transformer are less flammable and pose less fire risk, making them ideal for shopping mall, underground parking facility, hospital and other commercial areas. Oil-cooled transformers are used mainly in the outdoor installations due to the possibility of oil leakage and spills which pose a fire risk, but these units are more environment friendly. So not only on the fire risk part, I would also like to emphasize that if there is a leakage of this oil type transformer, with proper trenching, I need to take it to a nearest soak pit where I need to dump the unwanted oil that will be getting collected. So these are some important key points which would help us definitely in selection of dry type versus oil type transformer for any of our project. Now moving to the details of the transformer design. First, what comes in our mind is the tank or the transformer tank, which will house the core and coil assembly. So transformer tanks are mostly built of robust mild steel plates having a low carbon content. Transformer tank plate thickness has to meet the overpressure and vacuum test as laid down in the CBIP standards. Tank shall be suitable to meet the earthquake forces as per the installed seismic zone. So another important point, so we have to be very sure that the transformer, whether indoor or outdoor, are placed in which seismic location. It's seismic zone 2, 3, 4, whatever. So accordingly we have to design the tank which can withstand the earthquake force as per the seismic zone. Tank design and construction has to ensure that no internal pockets for air or gas can be accumulated. The transformer tank in the bottom will have bidirectional rollers with locking arrangements for the movement purpose. Tanks shall have a bolted inspection covers for inspection. The bolted connections shall have weatherproof hot resistant gasket to ensure oil tightness. Tanks shall also have a manhole for visual inspection of the core and winding assembly from outside. All fasteners has to be hot dip galvanized with zinc passivation for corrosion prevention. Provision of drain valve has to be provided to drain out the entire oil from the transformer if required in a case of eventuality. Earthing provision shall be provided preferably on the diagonally opposite sides of the tank for purchasers' external earthing connections. So one important point I would like to highlight. While some key important points are being highlighted or populated in this slide, there are much more important parameters to the design of the transformer tank which we have to take up. After the tank, it's the transformer core which is very important in the selection and design. Transformer core shall be constructed from high quality, non-aging, cold rolled, grain oriented CRGO electrical grade silicon sheets which shall have heat and oil resistant insulation on the both ends. Both sides of the core has to be properly laminated. The core material has to be BIS grade, preferably M4 or better. So in the BIS grade you can check there are multiple grades which are more advanced grade, which are costly and can provide a better loss on the transformer part. The thicknesses are measured in millimeters, 0.23, 0.24 or better, something like that. The core shall be boltless in the design. The insulation structure for core to the core bolt and core to the clamping plate has to undergo DC high voltage test of 2 kV RMS for 1 minute. That's mandatory requirement. Steel sections for supporting the core from the tank has to be sandblasted thoroughly after cutting, drilling and finally welding. Then another important point is regarding the flux density. So the maximum flux density at any part of core and yoke at rated voltage and frequency with 12.5% maximum voltage variation shall not exceed 1.9 Tesla as per the limits mentioned in IS 2026. So this we have to ensure, particularly while checking the data sheet filled in by the transformer for our approval. Lifting lugs are important because the core is heavy and you need to take it out for lifting purposes. So lifting lugs are mandatory, has to be a part of the core design. Then important point is the winding which will be placed on the core. So transformer windings are mainly made up of electrolytic grade copper. So any material, copper or aluminium, has different grades as per the IS/IEC standards. So the grade of transformer winding which you are specifying here is the EC grade or electrolytic grade copper. The winding has to be manufactured in a controlled environment free from the dust. A very, very important point. If there are accumulation of dust or any other foreign particles, that can eventually lead to a dielectric breakdown in the winding. So we have to be very sure from the environment where it is being manufactured. Preferably the class of insulation shall be class A for oil field transformer and class F or H on request for dry type transformer. The windings shall be brought out and terminated on outdoor bushing or cable box based on the voltage requirement or bus duct chamber in case of LT, which has to be specified on the data sheet as per the design requirements. For transformer having provision of terminating three-phase neutral bus duct on the secondary side 433 volts in the distribution transformer, neutral of the star connected secondary winding has to be brought out to a secondary terminal chamber. Very important point. So as we can see, there are majorly 6 types by which we can classify the transformer winding. First is cylindrical winding, second would be helical winding, third double helical winding, fourth multi-layer helical winding, fifth crossover winding, and sixth finally the disc and continuous disc winding. Now the selection of the windings which suits your transformer is exclusively selected based on the voltage requirements. So in LV we may use a specific winding which may not be compatible for HV winding for a particular voltage grade, whereas for a particular voltage greater than some particular value we may have to go for a specific winding, let's say disc winding. So it's manufacturer to manufacturer design. However, based on the selection design guidelines, we can take a call on which winding to go and which would be the most optimum design for selecting the transformer winding for a voltage grade. Transformer oil. So transformer oil is a very important part which acts as the insulation medium for the transformer oil field transformer. Transformer oil has to be supplied as per IEC 335 or IEC, it would be IS 335 or IEC 600296 type 1 mineral insulating oil. The transformers nowadays is mandatory to be certified for non-conformance of PCB, NPCB, non-polychlorinated biphenyls. The transformer oil has to be also tested for oil breakdown voltages. Next is transformer radiator. So oil type transformer shall have detachable radiator which you can remove for any maintenance purpose. The radiator will have provisions for isolating valves. Each radiator section shall be provided with detachable type lifting lugs with air release valve and drain valve. The radiator shall be rated to withstand the overpressure condition specified for the transformer tank. Shut-off valve shall be provided at each point of connection to the transformer part. So if you can see here, This is the, let's say, inlet, and this would be the outlet of the oil. So the oil would be recirculating in this particular radiator for the cooling purpose. Then an important aspect is the main tank conservator. So conservator is basically the chamber which houses a particular fill oil to meet the expectation of expansion and contraction that's happening inside the transformer, right? So in event of a fault, we already know inside the transformer the oil would become gas and eventually it will go upwards, right? In that case, when it goes beyond a predefined limit, the oil flows from the conservator to the tank, thereby maintaining the proper insulation level inside the tank. And vice versa happens when there is an expansion of oil that flows back to the conservator, thereby maintaining the tank oil level in the proper. Conservator shall have air cells for oil preservation system. Conservator shall also have drain valve with blanking plate for oil filling hole cap. One prismatic oil level gauge shall be provided at both ends of the conservator. In case of online tap change or OLTC, additional MOG magnetic oil gauge has to be provided in the OLTC. Silica gel breathers are used to check the moisture content that has happened in the conservator. Nowadays, preferably orange colored silica gels are used, which are environment friendly and non-toxic. So not we go for the earlier used conventional blue type silica gel breathers. They are toxic and not environment friendly. Nowadays we go for this orange type silica gel. Very important point is the transformer marshalling box. So all the OTI, WTI, right, all the internal wiring of the transformer has to wired to a termination box called transformer marshalling box. This box is mounted on the transformer and made of CRCA sheet steel. The internal cabling has to get terminated in the terminal box or marshalling box for external connection. Marshalling box also houses the mechanical gauge for OTI and WTI. So from the inspection window outside itself, we can have a look on the OTI and WTI windings, which the operator takes at a particular predefined time period in the site. The alarm and trip contacts and any other contacts has to be wired to the terminal block of the marshalling box. So this is a clear picture of the transformer marshalling box where we can see the OTI, WTI, terminal blocks, space heater, socket, switch and other MCBs. Now these were the part of the transformer design main important points. Now for the final stage, we have to have the pre-order documents, important documents which are part of the transformer request for quotation. So while we place an inquiry to our manufacturer based on the selection criteria and the parameters defined in data sheet, we do a request for quotation, or we place a material requisition that we float basically an inquiry to multiple vendors, and based on the inquiry the vendor submits the technical quotations, right? Once we receive the technical quotations, the technical quotation includes lot of technical data which are pre-filled by the vendor. Some data may not be submitted by vendor during the offer stage, which we have to clarify with vendor, and if eventually required in the offer stage itself, which may have cost or design impact later on, we have to ask for those data and get clarified in the order stage, pre-order stage itself. And some data which are not required but can be only furnished post the transformer design by the manufacturer, those data has to have been parked for post-order stage itself. So there are TQ stage, that is technical query stage, wherein all the technical queries that we face during the offer stage are being clarified by the vendors. So eventually we prepare a CRS form of a sheet where all the queries are being addressed and shared to the vendor for their reply and clarification. It's always fruitful and better that we close all the open points in the pre-order itself so that vendor doesn't get a room to play post-order with any of the data or parameter which may have significant impact in our transformer design. So that has to be ensured by the design engineer in the offer stage itself. Once all the technical queries are done, we furnish a technical bid evaluation sheet. If there are 3 vendors and we have multiple parameters which we require are mentioned in data sheet, so we prepare technical evaluation sheet wherein the data of all 3 vendors are put forward to have a view the compliance and non-compliance or deviation with respect to our required data, whether vendor are achieving or meeting those particular value or not. So for example, when I say the maximum flux density at the maximum voltage and frequency variation has to be less than 1.9, we can ask vendor in offer stage, are you abiding the same or not as per standard? So they can simply mention yes, yes, and if the third vendor says no, that becomes a big deviation point from the design point of view. So in similar ways, we do this technical bid evaluation, and finally we can say that these vendors are technically acceptable and we can give them a rating of T1, T2 or T3 like that. So T1 would be the most technically acceptable vendor in this particular quotation, and T2 being the second one and T3 being the third. Yeah, it's very important, and we have to keep in mind that it is not always that we have to go for T1, T2, T3 for 3 vendors. If there is one vendor who is non-complying many important parameters in the design, we can technically reject that vendor because with those parameters we cannot move ahead in our design, and so we can technically reject them in the technical bid evaluation stage. So these are the pre-order stage documents, the flow which I have discussed with you just now. So after placing the inquiry, that gets followed by the rounds of TQ where we clarify all the technical points with the vendor, clear from that part, and finally we do an independent TBE for the vendors, and we technically give recommendations for T1, T2 and T3. So in the post-order stage documents, that includes major vendor documents and drawings which we have already agreed with the vendor in the pre-order stage. I repeat my point, which are agreed with vendors in the pre-order stage. So we have to be very cautious that what are the post-order vendor documents that we are expecting from vendor as part of the vendor drawing requirements. If we fail to specify any particular document, vendor may object in the post-order to submit or furnish that particular document. So a detailed listing of post-order vendor documents has to be prepared as part of specification or MR sheet, which has to get agreed by the vendor in the pre-order stage itself. So the flow goes like this. For each equipment, we prepare a document which has to be furnished as part of inquiry stage, which we have to check in the inquiry stage itself for doing the technical bid evaluations. That may not be an exhaustive one, but maybe a precise document, right? The list which we can populate later with you all. And then we can set the expectation that post-order, what are the important documents or what are the documents that you need to submit us for our review and approval for go ahead in manufacturing. Without that, vendor cannot proceed. So till you give a manufacturing clearance post order in the VDR stage, vendor will not go for manufacturing clearance. So we have to be very clear with respect to the project timelines, as well as clearing all the doubts and communicating with the vendors so that the manufacturing clearance is provided on time, and accordingly vendor can take the lead time for the manufacturing and finally the shipment for delivery of that equipment at the site. So from the project lifecycle perspective, we have to look for the schedule when we need to finally give the clearance for this manufacturing clearance to the vendor, so that the timelines of the schedule for the project are being met. So the foremost last important point that I would like to touch upon is a very important point, that is inspection and test plan with quality requirements. So there is a document which we popularly call as inspection and test plan, wherein all the test, routine type tests, visual tests, dimensioning checks, incoming material supply check, everything is listed in details which vendor has to comply pre-order stage, right? So that list has to be populated to the vendor in the offer stage itself, and we have to take a proper compliance from the vendor on this inspection and test plan. This varies from organization to organization based on their specific requirement. However, the main important points which shall be part of ITP in terms of testing are already laid down in the IS, IEC and CBIP manual. So anyone who wants to look out what are the tests that has to be mandatorily performed, that's routine tests on any transformer assembly, are clearly mentioned in IS 1180 and IS 2026 standards based on the transformer rating. And if there are any specific tests which are not mandatorily performed, called type tests, for example, if I say temperature rise of a transformer, you have, let's say, specify 55 degree rise over a 50 degree ambient temperature as part of your data sheet, and you want to specify and you want to witness that particular test, your quality team or your engineer want to witness that test, right? You have to specifically mention that same in your offer stage document itself, that this is a particular specific type test that we want to witness at a specified testing lab. Now, during this testing and inspection, I would like to emphasize on one important point. Please take a note of it. It's very important that while many of the class 1 vendors in India do have a NABL certified test bench which says that they can do this type tests on their own NABL certified lab in their manufacturing facility, you know, there may be a chance of speculation with some data in their own testing lab. So many a times many customers request that we want to go and perform this test from an independent lab, can be ERDA, for example, right, located in Baroda. So this is a lab, ERDA. So they also do this test facilities, and many a time it has been seen the calibration of the instruments that are used for the testing are little different from their own set NABL lab versus the ERDA independent lab. So many a time there can be fluctuation in the data because the instruments are calibrated in the bench tool little different. So that is one thing I wanted to highlight. So we have to be very sure that what are the additional type tests we want to witness in our purchased transformer, and we have to clarify the same during the offer stage itself so that the same is taken care. Also mindfully we have to keep a notice that these tests require a schedule timeline, because we need to take an appointment from the independent agency if we are doing from the outside part, let's say ADA. So we have to send the transformer from the manufacturing facility to the independent testing lab agency. There they will perform the test. It will again come back and then it will be finally delivered to site. So the factory acceptance test and the site acceptance tests has to get populated or included in the inspection test plan, and accordingly factory acceptance test and site acceptance tests will be duly performed on the transformer. So with this note, I would like to take a pause on the transformer design. Hope you have understood the basic important points that has to be considered as part of transformer design.